So hey everyone, I'm Greg Tatum. So I've been working on Firefox DevTools for the past 3 years, and kind of for about the past 2 years I've been focusing on the profiler. And today I'm going to give a talk about the Firefox profiler and do a little case study on our own dealing with performance issues with the profiler and using the profile to profile the profiler. So we'll be using the word profile a lot in the next 30 minutes. So basically the kind of high level points I want to get through is with Firefox Quantum, we really work to change Firefox from a fundamental level, incorporating new technologies and validating that those were actually correct and good fixes that made the user experience better. So with that, we had to build a culture of performance across the organization. And also I want to talk about how performance affects usability. So building a profiler and it's slow, it's hard to use, that actually affects the ability for our users to even use the tool. So the performance of the tool itself is hugely important. And finally, whenever you're profiling, there's so much going on and you're writing code and you're kind of in the minutiae of all the details. So how do you identify and fix the real problems that your users are actually having? So for the first part of this case study, what I'm going to do is dive into a little bit of the history of performance tooling at Mozilla. Initially, there was this tool called Cleopatra, and there were all of the kind of names for internal Gecko components, which is the engine powering Firefox, were all kind of ancient world names. So Cleopatra was the name. I don't know if there's any meaning behind that or not. But the tool was built by Gecko engineers, which again, Gecko is the engine powering Firefox, and it was built for Gecko engineers. And so the tool surfaced lots of C++ internals and was really focused on solving specific and diagnosing specific problems with the engine itself, not so much of a focus on web developers. And then there's the DevTools performance tool, which is currently, if you open up the DevTools panel, this is the tool that you will find and see. This is not the tool I'm talking about, which can be a little bit confusing. So it was really, most of it was engineered during a time whenever there was a big focus on game development. And so there's frames per second graphs, and there's a bit of a smaller feature set, but it's actually built on the same infrastructure that the other profiler was. The trick is that this one uses, it doesn't surface any of the C++ stacks. It only uses JavaScript stacks and ones that are labels. It has more of a web dev focused, and some of the legacy of the DevTools and how the browser was built, Firefox has been, had lots of interesting ideas over time that develop into nice things. And one of those was Zool, that ended up prototyping some of the ideas behind things like the Flex layout. But the problem is that those technologies were aging, and this was the last new tool built using kind of a Zool-based layout, which is kind of an alternative to HTML. So there needed to be some significant investment to bring this tool up to date. So now we get to the Firefox profiler, which was previously called Perf.html because it was more of a web app, HTML-only technology. And it only recently got renamed to the Firefox profiler. But this profiler was used and built primarily, again, targeting Gecko engineers to surface and diagnose issues with Firefox and trying to figure out how to make it faster. And so this is deployed as a web app. So it's actually outside of the Gecko code base. It's outside of Firefox, and it uses a web extension to capture profiles and inject it into the web app. But then you have service workers and all that, so it feels like a nice, like just a normal dev tool. But what's cool about this is that we can take our profiles and separate them out from the browser, and then they are uploaded. So as you capture profiles, you upload them and collect them. And then all the information that you look at while you are going through the profile is all serialized to the URL. So what's cool about this is that you can perform an analysis, and when you're just chatting with someone on Slack, you share a link and you get there. From the tech side, the DevTools team has been using React and Redux to handle the front end and state management. And so this tool was also built in that tradition, which really helps our teams be able to collaborate and work together and use similar practices and share things across projects. And the tool is built by Mozilla and the community. So there's a ton of people who come in and help make these things happen. And thank you for all of our contributors, because you all are amazing. So let's talk about this project progression. So this new profiler gets going, and it starts as a heroic prototype by a single engineer. This is Marcus Stange, Mozillian, and he started just furiously programming away. And he worked on the profiler and the old Cleopatra version, and started furiously programming. And then Firefox Quantum got announced, and all of a sudden we realized, oh my goodness, we have to build infrastructure and figure out how to take all of these crazy new technologies, integrate them in, and provide first-class performance analysis on them to see if that's even like a good thing. Was this a good decision to put in an entire new style engine? And so I switched over from my other work on DevTools and started contributing to this project. And Firefox Quantum had a very tight deadline. So it was the matter of, okay, now we have all these engineers using this product that one person heroically started. How do we build it, deliver features quickly, and still provide value, and not compromise on building a good product? And at this point, we have a dedicated team working on this, and supporting it full time is it's not just someone's heroic project. This is a supported thing that is supported through leadership, making sure we have resources to do the job we need. So this will tie into how I want to talk about building a culture of performance and how we did that. So if you're building a profiler, what's the criteria for success? Basically, anyone who's working on the product needs to be able to fix performance. And you need to be able to answer the question, why is it slow? And ultimately, you need to make Firefox faster, make the end product faster for everyone. So with that, I'm just going to give, now I've kind of talked about the history of it, I want to give a little kind of lightning tour of the different features that we built out. So that's not just words on the screen, you can actually see some shiny UI. So we've got a multi-process timeline that can correlate all the different processes that are going on in the browser, because the browser environment is getting increasingly more complicated. And so this tool really focuses on looking at, are we adequately making things parallel? Where is the work happening? How do you diagnose what is doing the work? And we have screenshots on the timeline track to be able to correlate exactly in time where things happen. A relatively recent feature is categorized stacks. So the wavy kind of chart and the colors, if you hover over those in the UI, you get a tooltip showing you exactly what category it's from. So you can see there the yellow is some kind of JavaScript happening. And what's kind of fun is the orange to the right is the garbage collection happening. So you can see just from the amount of area the graph is taking where time is being spent. So if you're triaging and finding performance problems, you can quickly dive into the areas and teams that might be able to help make the relevant fix. And of course, the great flame graphs, and we use the term flame graph to mean a summary over the entire course, so it's a percentage-based view, and then the stack chart we use to describe the kind of similar view but based over time. So the x-axis in this particular chart that I'm showing is percentage of overall time. And again, using those same colors for categories. And the extremely popular call tree with our engineers breaks down everything into that. It's actually literally the same data structure as the flame graph, but it's broken down into a tree table type of view. And one thing that you might notice from other more native instruments has these features is we can actually modify the call tree and go and change the shape of it by performing operations on it. So if you want to focus on a function, it takes every place that function was called and reroutes it as the root node of that tree. So those were those were really fun to figure out how to program. I did not like that. And finally, network track, see correlate network information, where we've got profile formatters, profile format importers, so we can look at and cross-compare with Google Chrome, with taking native profiles with Linux Perf profiler, and we have an intern over the summer for the Google Summer of Code working on instruments, which will be exciting to have. And finally, again, the upload and share. That's one of the links. We have short links as well, but you can literally just click on that, and it will take you to the full UI. It's a web app. It's built on web technology. So let's get part of the talk about profiling the profiler. DevTools is extremely recursive when you're working on them. I was working on the inspector, and at one point I had 4 inspectors all open at once inspecting each other, trying to figure out what was going on. And luckily I had a big monitor because I was just like, I don't know, this one's pointing here and this one's pointing here. So there's usually this kind of really weird space that you get in. And if you are using the tool to work on the thing, it means that like I was just profiling the profiler all the time. It was a great use case for it. So maybe I might have over-optimized for my own use cases, but oh yeah, and so the profiler is typically CPU bound. So we don't have a lot of network resources to optimize. So there's a lot of strategies around that. But what I'm going to talk about is primarily looking at something that is CPU bound and the strategies we used using JavaScript to write code that did not just crunch away forever. So again, Cleopatra was the original performance tool. It used web workers. And so there's this idea that you can spin up a web worker, throw arbitrary work at it, forget about it, and you get your result back and everything's fast. In this case, it was still slow. You load it up, and you get this nice little spinner that you can sit and watch, but it would still take a long time to get the results of what was going on. So one risky decision that we took with the profiler front end that I was kind of hesitant about and I got some pushback on was just to completely avoid web workers for most cases. And really just embrace the jank. So one example here is the focus subtree operation, which I alluded to earlier. In Cleopatra, it took 8,000 milliseconds. So you click on it, and you sit there and wait and go get some coffee and come back. And the new UI, it took 160 milliseconds. And it's similar people working on the same product, but with different approaches on it. So how do we go from something that is just extremely slow to something that is much faster? So fast UI is just fun to use. If you're sitting and waiting on a spinner, you're frustrated and mad, and you don't want to keep on working with it. So when it's fast and fun to use, it makes doing these types of analysis easier. So let's talk about some specific fixes that we used. And I was kind of looking through and thinking, like, how do we make things fast? And there were so many tiny paper cuts all over the place. And so this is our specific case and probably will not generalize to everyone. But I think it's useful to kind of share some of the things that we did. The JSON structure that we get for the profile format gets spit out onto the page. And we do a one-time processing step, but from then on we treat it as immutable. We never actually change it. And so if we want to do any analysis on it, and that's constantly what you're doing when you're diving into the views, kind of rerouting trees, slicing into specific parts, we used memoized structures. So you call a function, and if it has the same parameters, you get the same results. And so that just took off a whole mental strain on how we dealt with an increasingly complicated environment. And with that, we use shallow clone. So rather than doing deep clones of all these really deep nested, complicated data structures, we would just copy out the small bits that we wanted, modify it, so we might just have a single array and then all the objects is attached to, and the rest of it is all the same. And in fact, the act of pushing things to workers was what was mostly slow of cloning all these complicated data structures. And the next 2 points are kind of an interesting point. Having lots of tiny small objects ended up being slow. So we ended up using lots of long arrays. So if you think in terms of an SQL table, and you have if you have 4 columns in it, you could represent that as one array, and each row in there has an object with 4 properties on it. Well, if you have 10,000 of those, you're going to have 10,000 small objects. That ended up being slow for us. Lots of garbage collection was happening. We were throwing away data like crazy. So instead, you take that same SQL, and you have a single object representing that table, and instead you have 4 long arrays all filled with the data. So that is much easier for the garbage collector to handle and work with. So that was kind of one strategy that we used for our specific data structure. This next slide is probably one of the biggest points, but it's the hardest one I find to talk about, and probably should be its own talk. And even then, it requires kind of an analysis of it. So optimize the big O. Using big O is all about what is the complexity of the algorithm you're running on your underlying data. There's lots of literature to help support it, and so if you are looking at something to beef up, get some good articles on it, look up how to think about it, and it's a useful way to talk to your team about how to find those things. And so I have this rule written down. Users will add orders of magnitude more items than you expect. And originally I put an order of magnitude, and then I went ahead and said orders of magnitude, because a lot of times I design something for like, oh, you're gonna have like 1,000 items here at most, and then I'd get 1,000,000. And it'd be like, well, this thing's slow for this profile I recorded. Oh, well, yes, it's because you have 1,000,000 markers in here that you're chewing on. And so I'd get these profiles, and then I'd profile it and look at, like, why is this slow? And I'd identify something that had a bad complexity, and I'd reduce the complexity of it. And with that, again, I feel like this is somewhat hard to give like a nice nugget on. But the specific fixes is like use the right data structure for the job. So for instance, anytime I see an array and someone's searching on it, I get a little bit nervous. So searching a big list of 1,000,000 items is going to take some time, and if you do it a bunch, it's going to take even more time. So if it's a unique set, you can use the JavaScript set instead, and then you can almost instantly get things out of it and see if it has it in there. Is the list sorted? You can use a binary search, and all these have different specific complexities that are faster than just doing a naive search through an entire list. Does the data fit in a tree? Trees have lots of nice structures. They can help you from updating in lots of different ways. A lot of times, if you do a little bit of research, you can find different algorithms that help you with some kind of lookup into your data structure. So looking at it, you can think, I've got it shaped like this. Can I do a one-time operation to make it look like something else that is easier and faster to work with for the computer? And sometimes that means your code gets uglier. So you don't want to do this unless you have to. So profile to find out that it's actually worth it. And if you do something that's like really cool and it's not faster, delete it. Another one which is I think ties in a lot to using kind of the React Redux workflow is minimizing updates. And so if you have a long list of items on the screen, virtualizing them so that it's only showing the view that you're looking at. We use a lot of canvas calls, so making sure you're not drawing too much. Minimize updating and touching the DOM. Minimize all of our React component updates. These were all like really important fixes, and oftentimes it was when you profile, this is what shows up. The last point on specific fixes is to profile, 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 and a few more. That really is kind of like how you find and know that you have a problem with it. So for me, this is one really big lesson learned from working on the profiler, is working on a dev tool. I got this sentiment a lot, especially working on a tight deadline. Just build this feature. I'm an engineer. I don't need it to be pretty. Because the idea is I just need to perform my analysis. I don't care if what fonts you use, what colors you use, if you have a design system. I just need to be able to load up the tool and get my job done. Which is really funny whenever you get this other sentiment a few weeks later. The tool is so fast and nice to use. Thank you so much. which is amazing when you have the users of your tool sitting in or I'm a remote worker, so sitting in the same video call as you. It's really easy to talk to them and get feedback. So what does pretty mean, and why is that important? For me, I think it means quality software. It means with UX, you fix your users' needs. For performance, you make fast and responsive code. For, again, UX, you want to lower mental overhead, especially for like, building a dev tool. It's complicated. You're stressed. You have a problem. You want to get it fixed. You don't want your tool to get in the way. And on the testing side, don't just build the feature and let it break. Write tests, increase your reliability, and just don't break. And if you're trying to like make the case of why you focus on performance, a fast program really is a joy to use. Whenever you can do something as fast as you want, that's really nice. It's less wasteful of resources, of computing resources, of expensive engineering time. And this nice thing is that all of a sudden you have more capacity to push your code to the limits. Before I could only handle a list of 10,000 things. Now I can handle a list of 1 million things. I can do a lot more analysis and crunch that information real time, a lot easier. And again, whenever a user complains, and we had users who I could just hop on a video call or Slack or IRC and chat with, a user complaint for me was always kind of an exciting moment because it was a great opportunity to improve a key metric. And if I heard multiple users complaining, I made sure to shift around my priorities to work on that. But you can't just have one person, you can't have one heroic engineer build a tool and hope that it works. You need infrastructure and team and support with that. And so with that there needs to be a culture of performance. For us, it was building a profiler. One small piece of this was just making the tools accessible and easy to use for our users, surfacing the relevant information they need, and then as we had success and documented those successes, it just kind of fueled the engine and kept it moving. And ultimately, having support from leaders, whether that's managers or tech leads or just having the organization be supportive of it, I think is a key component of it. So yeah, that's my talk. Thank you all so much. Thank you, and have fun profiling.